Champions! Got a Vibro champ here. Reported humming. So we're going to go through the process of determining what kind of hum it is and turning it on for a brief period and taking some measurements to try and pin it down as quickly as possible. So I'll get this out of the cabinet and we'll hook her up to various measuring devices and we'll figure out what's going on. Alright, it's got a Weber replacement driver, a 1279 according to the sticker, so that's an 8 ohm. Looking for 3.2 ohms on these, but 4 ohms near enough, but 8's a bit of a push. So we'll give it a quick sweep anyway and just determine if there's anything wrong with the driver. Learned this the hard way. Oh, on square wave, that's a bit aggressive for this time of the morning. Doesn't sound like any weird buzzers or anything like that, so I think the speaker's fine despite its mismatched impedance. Oh, so this is a 120 volt. It's got the big rubber cord there, possibly original. 15 amp, 125 volt. So I might give this customer an option. It's a pretty small transformer, reasonably expensive. It's not really a collector's amp, so it's already been modified. Someone's got a CE manufacturing multi-section cap on there. That's interesting. It says it's rated at 85 degrees down there, but every one I've seen has been 65 degrees, so I haven't bothered buying them because 65 degrees is fuck all. So maybe there's a bit of oh well, no one's buying them, let's just change the label. But that's been replaced at some point. I can't find anything that would allude to a date code on there. Oh yeah, 02, maybe 2017, 0217-01. I'd have to confirm what that means. It looks reasonably fresh, you know, like I don't think that would be 2002, so I'd say it'd be a February 2017. So the valves, we've got a Bryma 6V6, black tube, and we've got an RCA 5x3. That was sitting a little bit loose. They've got these shitty brown sockets that the contacts are like way down inside the pinholes, so they make really dodgy contact with the valves. You see how far down in there the contacts are. I mean, maybe it was a safety consideration, but they really only grip onto the last 2 or 3 mil of the pin, so not very reliable. I'll probably just retension these and see how they go. Give them a clean. I don't think this guy wants to be in for a full replacement of the sockets. We've got a Fender .7025, and we've got a Jan 12AX7. Pins are pretty dirty. So there's been some work to it. I haven't seen a death cap mounted like this before, but it may be original. It's got the shitty brown bubbly flux down on that dodgy solder connection to the chassis, right next to the screw. They sort of screw it and solder it. Best of both worlds, right? Well, you know, neither of them really work that well, but there's no need to have this with a 3-pin plug, so that should have been removed. It's actually a bit of a hazard if you haven't got the greatest ground connection on your socket. It can energize the chassis. Limited, providing this cap is in good condition, limited current, but this is rated at 125 volts AC, and this is probably seeing at least 125 volts AC, so it's right on the edge. It's not a safety rated cap, it's not an X or Y class cap. It's coming out. If I do the job, if he approves my quote, it's getting removed and it's going to be specified in it. And if he changes this transformer, we'll be changing the mains lead anyway, so we can rewire it a little bit safer. So it does have the mains going straight to the wrong way. Has the mains going straight to the hot going straight to the tip of the fuse, which is good. And then it comes from there to the switch and then to the tranny, and the neutral is hard connected, so that's fine. Whoever's replaced this cap, not great solder connections there. I'll be looking for some kind of mechanical securing before soldering instead of just melting the solder and going plop and sticking the wire through. It's not great. There's been a output bypass cap replaced with a Sprague, and all the other bypass caps are still original. So I'll be changing them. You know, they still perform okay, better leave it original, mate. Well, you know, caps are what, older than me significantly, and you know, I'm not looking that great, so but yeah, nothing's gone bang, so I'm thinking we chuck some meters on it, fire it up and see what's going on. Just check the fuse rating. Little fuse, 1 amp, 250 volts, sweet. So 1 amp at 125 volts. If this, if we convert it to 240 volts, it'd be half an amp. Same amount of power, twice the voltage, means half the current. So this replacement cap here, it's a 4-section, 20 microfarad per section can cap. On the first revision, the what is it? AA764? Yeah, AA764, there was 3 filter caps, 20, 20, 20 microfarad. On this one, it was 40, 20, 20. So the first cap that the rectifier outputs to was 40 microfarad. So in this case, 2 of the 20 sections have been paralleled. You can see the wire there goes between 2 of them, and then you've got 20, 20. So you've got 40 there and 20 there. 40 can be a little bit much for these 5Y3 rectifier valves, so that's one thing we'll be aware of. Maybe we've lost rectification because we've shorted a valve. So one thing you can do is swap it over, so the first node is 20 microfarad, second one's 40, and that's something that that Lyle pointed out in his vids on Psionic Audio as well. It's a way to extend the life of the rectifier valve, so we might look at that as well. Alright, so we've got our mains sitting at around 244 volts. We've got a step down transformer here that is supposedly outputs 115 volts AC. It's currently putting out 123 volts AC. This amp says 125 volts on the back, but the schematic also says 115 volts. So there could be a bit of discrepancy between the expected voltages in relation to the mains input. Best way to reference where you're sitting is look at the heater voltage and use variac to adjust until you get 6.3 volts on the heater, and then everything else should be relative to that, so you can take into account any mains fluctuations and bias the amp to be on the safe side with that in mind. So here I've just got a couple of adapter cables, little adapters I've made up. So I've just got a 1/4 inch plug coming from my test cabinet, but this just choosing the terminals for each specific amp just makes it easy to have little adapters. So I've got the 1/4 inch spade connectors there, Got the 4.75 spade connectors there, just normal terminals there for if you've just got bare speaker wires, and got the RCA, which this one needs, so we'll use that. Rightio. So first we're just gonna slowly ramp it up and get the rectifier warmed up and see what this hum is that's been reported, and just be monitoring the mains frequency on here, the mains voltage on there, sorry, and the first and second nodes on those 2 meters. So that's the plate supply and then the screen node. So we'll just slowly bring up the variac, watch the mains go up, 30 volts. Current sitting at about 13 watts, and that is about 10 watts idle at 120 volts. I just checked with both the transformers, the step down tranny and the variac being energized. So basically I'm just using the variac to change the voltage and the step down here as a glorified mains adapter, because I dug around, couldn't find my adapter, but you could just use a US style plug adapter in the straight in the output of the variac and forget about the step down and just watch your mains voltage and just use that, which is what I normally do. So we're drawing bugger all. We've got 150 volts, 160 volts. Should start hearing some signal soon, although it might help if I turn the signal Jenny on. And I'll set that to 1 kilohertz. Alright, we're starting to get signal now. It was just the RCA jack's a bit fiddly on the speaker output. It needs retensioning. So, we've got signal. Just check that node, 199 on the screens. Volts on the cathode. So let's, now we're happy it's not going to blow up, let's piss off the variac. We'll give it full mains on the primary of the step down tranny. Alright, so we've got full mains on there. You can see 120 volts AC, strong signal, and we've got a hum that's independent of the input signal. So I'll turn the signal Jenny off, crank up the input. You can hear the hum there. There's almost no change in hum according to where the volume control is set. Just check while we've got it up and running. Just check the vibrato works. Yep. Little bit clicky, but that is modulating the hum. So what that tells us, since this modulates the bias of the output valve to generate its vibrato, that's also modulating the hum. So the hum's coming from that stage. So very likely that it is the filter cap. So since we've just got our meter attached there, we've got this one attached to the plate node, let's just check the AC volts, the ripple. We've got 2.2 volts AC. Now that may not seem like much, but it's a single-ended amp, so you don't get common mode rejection from the top and bottom like you do in a push-pull amp. So that'd be very good ripple for a push-pull amp, but in a single-ended amp, not so much. Let's just check the screen grid too. So just note we've got about 24 volts on the cathode there. So I think from memory that's pretty hot. Volts AC on the screen grid node, that's 0.6 volts. On the preamp node, it's also 0.6. So what we'll do is we'll sub in a known good cap, and we'll disconnect that one so we don't overload the rectifier, and we'll see how that affects the hum. Alright, so just testing the resistance of the cathode resistor there. 488 ohm. We were dropping 24 volts and sitting at around 400 volts on the plate, so that's about 130% dissipation on the 6V6, which is pretty bloody hot. Not brilliant for the life of the valve, so we might cool that down as well. That poor little resistor in there is copping a fair bit of the poor little capacitor there is spaced pretty closely to the resistor as well, so it's copping a bit of heat from the cathode resistor. Ideally, we'd like to change that resistor out with a different value and up the resistance a little bit to cool that down, and move that cap a little bit further away in the process. So we'll see if the leads have got enough slack on them to do that. So one thing of interest here is this cap, according to the stickers, rated at 475 volts DC per section. So when you first switch the amp on, she starts conducting. It pushes up to 490, almost 500 volts before the 6V6 starts conducting. So the 5Y3 is actually a pretty quick starting valve, and that was from cold. What we kind of want in an amp like this is a slow starting one, so you don't get that pulse of high voltage which exceeds the cap voltage rating and could play a part in damaging it. Alright, so I've just got my fluke up here on capacitance setting. So we'll test the each node. So that's the first cap, 24, second cap, 24 microfarad. They were paired together, so that would have been 48 microfarad in the plate node, so B plus, whatever you want to call it. And then the preamp node was again 24 microfarad. And a screen node is measuring open lines, so it's not a capacitor anymore. Now the ripple on the screen node and the preamp node were about the same, so it's kind of weird. But yeah, I've disconnected it now, and it's clearly showing that section's failed. So what we'll do is just quickly sub in some just dodgy axials in there, and then just make sure that gets rid of the problem, and then we'll fire through a quote for possibly leaving that cap in place and removing this tag strip, which isn't needed because all it houses is the cap which we're removing. And then we're going to mount through the existing holes, which I've done this before on others. We're going to mount a longer tag strip, and we'll just directly mount axial caps between where they need to go, those three nodes, and then we'll ground them all on a common point on the other end of the tag strip. So that will make it nice and easy. It looks original-ish from the outside because you've still got the can cap sitting there, but it's disconnected, and we've got you know, caps that are available and reliable mounted within the chassis. So that's the best way forward. Alright champions, what you're looking at now is a super sketchy rig. I just got some F&Ts floating in midair there, grounded to the common point, which isn't ideal, but it's a fender. And we're gonna just fire it up and check the ripple on each stage now and see if we've still got that hum. Boom. So we're watching the AC volts on each node. Now we've dropped it to 22 microfarad on everything. So now we've got more ripple on the first stage, but we've got less on the later stages. And as you can hear, no hum. A little bit of background hum there, a lot less than it was. Probably courtesy of that lower value on the first stage. But I think it'll be safer for the valve. And it is pretty damn low. I doubt the mic's even picking that up. So, proof of concept. we can write up a quote, and I'll see you when it gets approved. Rightio, well, we've got it up. Let's have a quick listen. So we've got everything at about midway. Typical sort of boxy sound, which we might be able to address if the owner wants to make a few value changes to the tone stack. Ooh, that sounds fucking terrible. That sounds like oscillation as we push it harder. So there might be a lead dress issue. So we'll dig a bit deeper into that as well. Yeah, sounds terrible. So there's something funny going on there. Might fire up the scope and see what is going on. Alright, so I got in touch with the customer, offered him an option quote, because he did say he was interested in a 240 volt option, so that means replacing the power transformer and replacing the mains lead, replacing the fuse, and also just going over the whole thing, changing the remaining bypass caps, changing the cathode resistor for the 6V6 to get it to a bit more of a sane output dissipation, and replacing all the caps as aforementioned with the new tag strip with the new axial caps, and leaving the existing can cap in place, just disconnected. Way too expensive. So he expressed interest in all of these options when he dropped it off, and I sort of gave him rough ballpark figures, and yes, send the quote. Oh no, I was expecting $200. The sort of stopgap measure, which I can't warranty, but it'll get him out of trouble for the next couple of, I don't know, months, until another section of the can cap goes down. Just remove the depth cap and disconnect that one node, which was, well, basically we're returning it to an AA764 at the moment, so 20 on each node. The hum's improved, is still slightly there, but it gets him out of trouble, and probably see him once he's saved up a bit more, and we can get the full works burger happening on this thing, because it does deserve it. They are cool amps, but you know, the same old answer, I could buy a new one for that. It's like, yeah, you could, yeah, but then you're gonna have to do the same stuff to it. So anyway, I digress, so I'll just do this and put it back in the box and send it out. Alright, so we've removed our F&Ts, just wired it up, and got 3 out of 4 of the sections of the can cap in circuit. Fire it up, we've got it, all the meters set to DC on the 3 different nodes, going plate, screen, preamp. We're just going to watch the DC voltages rise too quickly. And then we're going to switch it over to AC and check for the ripple on each node. So bang, she's up to voltage 450, 475, 480, 490, and that's 15 volts. What is it? 475. So that's over the rating of the cap. Not sure what the surge spec is on that, but so we've settled down to about 390 on the plates, 380 on the screen, 347 on the preamp node. Flick them over to AC. Now we're up to about what we had with the F&T, 4.3 volts on the B+. Oop. Something just made a noise. Probably the cap already failing. Keep an eye on that for a sec. 4.3 volts, 0.8 volts AC on the screen, and about 150 millivolts on the preamp, although that's jumping around a bit. So there's something funny going on there. Yeah, look. It's either do it or don't do it, eh? So I think I'll just give it back to him and say, look, it's basically going to be pretty unreliable until we do some significant work to it. You can see the ripple jumping around quite a bit there on the preamp. Could be the resistor starting to fail, the dropper. Could be the valve socket being a piece of shit. Yep. Something's humming there. It's gone up to 4 volts. That's on the screen grid. So that could be a short. So what we might do is turn it on again and check the DC volts on that node. See what they're doing. We saw the ripple increase dramatically. If the voltage drops significantly there, we know we've either got a shorted cap or a short in the valve. So 380. So we've got a failing cap. The voltage isn't dropping, DC volts isn't dropping, but we're losing filtering on the second node. The first node staying about the same. So yeah, cap's fucked. Joy. Alright, so we've disconnected all those sections of the capacitor again. Now that was our first node. Still at 24 microfarads. Screen node. Open line. You just watched the cap fail. Third node, 24. And fourth node, open line. Another one bites the dust. So, recap, only solution. So a few other techs we've been arguing recently with would probably just replace the 2 sections that were failed with axial caps floating or something, because there seems to be this attitude that don't fix what isn't broke. I don't know how they're still in business doing that, because I go well and above the Call of Duty all the time, and I still get caught out all the time. Like every third job, something unexpected happens, and in the customer's mind, you're the last one that looked at it, so it's your fault. So you got to fix it. These other guys that only change what's literally exploded. They don't even have the equipment or know how to measure, like just AC ripple, like just what we were looking at here. We know that cap failed partially from the sound, the effect on the amp, and also the measurements confirmed it, so we know what's happened. This whole I don't want to replace it because it's stock thing, everyone goes back to the car analogy. One of the guys actually said to me, if you take your car in for a service and they change your tyres, you know, would you be happy with that? Well, if my tyres were 60 years old, yes, I would be happy with that. I'd go in there wanting them replaced, like. So, you know, that's where his analogy fell down and mine got confirmed. So, 60-year-old caps, yeah, that's bad. But this one is a replacement, relatively modern. CE distribution, possibly from 2017, looking at the code. But it's getting smashed by that quick starting 5Y3. And it's going over voltage. So that's probably punched these caps in the face repeatedly every time it gets turned on. And eventually they said no more and gave up the ghost. So the new caps we're going to put in are F&T axials. They're rated at 500. So looking at those voltages we had before, they were pushing 490, but not really exceeding that. And that was with the voltage being a little bit high on the main side. So we're going to put a 240, proper 240 volt transformer in it. I just talked to the customer and allayed a few fears about it. wants to delay it a bit to get the cash together, but essentially he loves this little thing, and I said, I gave you the options to make it last until I retire. So the price seems high, but you're getting 20 years of reliable service out of it, and in my opinion it's worthwhile. And he saw that view and he agreed to the quote. Just going to give him some time. Going to get the transformer on order. That's a proper 240 volt primary from Hammond, so the voltages should be a little bit more sensible throughout the amp, and we've got an extra margin of error on the 500 volt caps instead of the 475s that it's currently got. So we'll leave that cap in place so it looks cool from the outside and we don't have to worry about plugging that hole to avoid fingers wandering around. And we'll mount the capacitors, like we said, on the tag strip within the chassis. So by the time you see this, I'll have the transformer in stock and everything will be done and the customer will be happy and be tested, will be out the door. But in the meantime, I'll wait for the parts to come in and wait for his go ahead. We're probably talking another 3 or 4 weeks until he's got the funds together apparently, so then we'll shoot ahead with it then. So from the past, hello future people, talk to you then.